So let's get started. And so hi everyone. And as part of this webinar, we'll go through the multi-cloud strategy and what exactly does it takes, from being just cloud enabled to being cloud vendor agnostic. So a little bit about myself and so, hey, this is Sachin, and I am a co-founder and chief technology officer at Goavega Software Incorporated, which is an offshore product engineering firm. And I've been playing with software starting from the DOS days, and I've worked on different technology stacks, and now I pretty much do a lot of stuff on the cloud. I'm also an occasional guitarist and a nature photographer. My social links are on this slide, so feel free to connect with me on Twitter or LinkedIn. I don't use Facebook, sorry about that. Okay, so a bit about Goavega. So who we are. So we are a product engineering, design and tech house, that basically helps the clients design, develop, and deploy products for the connected world. Almost all of our clients are on the cloud, and we pretty much run all of our operations on the cloud ourselves. So in a way, we dog food and we walk the talk when it comes to the cloud. So when it comes to the cloud, Goavega pretty much is multi-cloud enabled itself. So we have our apps deployed across, and I'm talking about enterprise apps. So we have our enterprise apps deployed across all the big three cloud providers, be it AWS, Google Cloud, or Azure. And in fact, it's been like 5 years since we've been in operations, and till date, we've been running with 0 on-prem servers. That means we have absolutely no IT infrastructure that we maintain within our premise. Everything is on the cloud, including our Active Directory. Okay, so now coming to multi-cloud. So what exactly is multi-cloud? So a multi-cloud is basically a cloud approach, where you pick more than one cloud service from more than one cloud vendor. So when we talk about cloud vendor, we are talking about, companies which have a cloud offering, be it as a platform as a service or infrastructure as a service, and it could be a public cloud or it could even be a private cloud. Now, multi-cloud basically refers to the presence of more than one cloud deployment of the same type. So, when we say same type, it could be a public, more than one cloud deployment of public type, or it could be more than one deployment of private type, where each of these deployments are on different vendors. So taking an example, you could have an application running where parts of it are on AWS, which is a public cloud, and the rest of it may be running on Microsoft Azure, which is another public cloud. So excuse me, a multi-cloud is a little different from a hybrid cloud. So there are two different terminologies that we need to understand. Hybrid cloud is basically a mix of both public and private cloud, and with some form of integration or orchestration between them. Whereas a multi-cloud is pretty much having same type of cloud, be it public or private, just deployed across different vendors. So, one of the key reasons is like when we are building any software, be it enterprise or any application, we are, have a question, or, we are generally faced with a challenge, which cloud provider to pick. So, why can't we take advantage of the cloud scalability, the innovative service and the geographic reach that the cloud provides without, being worried about getting locked into the wrong provider? So, one of the key thing is, why can't we still just write once and run it anywhere when it comes to the cloud. So, that's pretty much, why you would want to go for a multi-cloud strategy. So the rest of the sections, the rest of the next of the few slides, we'll try to cover these. So, one of the top reasons for, going multi-cloud would be, obviously redundancy. When you have an enterprise app, and let's take an example. Let's say you were building something or running something off scale of Amazon or Azure, or a Flipkart. And when I say Amazon, I'm talking about their retail site, Amazon.com. And if you were completely on a single cloud, you still were pretty much relying on one cloud provider's availability. So, we've had instances like very recently up to last year where Azure was struck by a lightning strike in their South US data center, which brought that entire data center down. And it just didn't bring that data center down, it brought down even the North Central US data centers. So even if you had redundancy within Azure, by deploying, let's say, your application on 2 different data centers, if you were one of the unlucky few who was using the North and the South Central US data center, you would have still gone down. So redundancy is one of the key factors why you would want to look at a multi-cloud strategy. Then obviously comes the part of vendor lock-in. So every cloud provider, just to ease the development process and to give you a nice seamless integration with their past offerings, provide you SDKs. So, you would have an SDK for Azure Service Bus, you would have an SDK for, let's say, AWS SNS in the language of your choice. So it hardly takes, couple of minutes or hours to integrate into a service bus or an SNS. But what happens with that is now your application is deeply integrated with a particular vendor, and it's a little hard for you to move out, right? So if you're looking at tomorrow to migrate that app from AWS to Azure or to Google Cloud, you run into an issue that now you have to refactor your entire application and remove the bits out which were very vendor specific, right? Third reason would be obviously cost optimization, right? And when we talk about cost optimization, even though almost all cloud providers have a very competitive pricing, there are still few pieces which are much cheaper on one cloud versus the other. For instance, if you take SQL Server itself, Azure SQL is much cheaper compared to the counterpart on a GCP, right? So cost is also a pretty good factor when we talk about why you would want to move to multi-cloud, and especially when we're talking about a scale of, let's say, a Netflix or an Amazon. It makes a lot of sense to see how we could cherry pick these resources. Could we pick some parts from AWS, some parts from Azure, maybe some parts from Google Cloud, and have one system or even maybe multiple systems deployed across them. Lastly, there is also data governance part. So even though clouds have, or the cloud providers have a pretty good outreach when it comes to geographic region, there are certain data policies or laws that have come into picture recently, like GDPR, which requires you to put data close to where the end user is. And not every cloud provider has data centers maybe in regions where you have your user base. So it makes sense then to maybe pick a cloud specific to your application, which is much more in geographic proximity than the other cloud. And one final last thing on this is, one of the other reasons why a lot of enterprises nowadays are on multi-cloud beyond these four reasons is also what is called as shadow IT. So a shadow IT is a concept that we, or most of the people from development background would understand. A shadow IT is pretty much, IT applications and infrastructures that are managed and utilized without the knowledge of the enterprise's IT department. So what it means is, so let's say maybe I'm a dev working in an organization and I like Google Cloud. I want to try Google Cloud. So I might deploy an application on the Google Cloud, because now spinning off an instance on the cloud is like hardly 5 minutes. Anybody can actually go ahead and deploy. All it takes is put a credit card. Anyway, everyone gives you at least an year free worth credits, and you now have maybe the approved cloud provider by the IT was maybe AWS, but we as devs ended up hosting small bits of applications, maybe like proof of concept, or maybe because we like the other cloud platform better on the different cloud. So if we look at the current trends on the three big cloud providers, and when I say three big cloud providers, we are talking about the AWS, Azure, and Google. The AWS is obviously the clear-cut runner or the winner, and Azure is kind of catching up. If you look at 2019, Azure's adoption has greatly increased. Google, maybe my take is next couple of years, Google has been very aggressive with their cloud platform recently. And I think maybe in the next couple of years, Google's also going to catch up with AWS and Azure. So even though right now AWS is the leader, I would think that take 2021, 2022, all the three clouds are going to be pretty much neck to neck, which makes the jobs of the tech team that much harder, because now we have to see, hey, which one works the best for us? And sometimes there is no, clear-cut winner. For example, if you want to, let's say, run a PHP code, it's a little hard right now to run it on Azure Functions. It's much easier to run it on Lambda using layers. Or, if you're looking at Golang, maybe Google Cloud is the best choice compared to, AWS or Azure. So the key here is, we need to pick the right tools that work for our application or that meets the end business and technology goal rather than picking a vendor. Okay, so there was a survey done by the Wright Foundation and for the top enterprises across the world. And as of 2018 July, the Forrester survey said that at least 86% of the companies surveyed already had a multi-cloud strategy. And 32% of those were using different cloud providers for different applications, whereas 14% were using different cloud providers simultaneously. So what it means is when you talk about the multi-cloud strategy, there are two ways to look at it. One is you have a pretty large enterprise application and you could run different components. And if you're talking about, microservices, you could run different microservices across different cloud providers. So basically a single app could be spread across different cloud providers. So let's say we have a web app or a web application. The front end could be hosted on, assuming we are building a single page app, the front end could be hosted on Azure Blob, which is the HTML Spa, could be a React or an Angular app. All the microservices might be hosted in let's say AWS Lambda with an API gateway. And you could finally have maybe the database or a NoSQL hosted on Google. So that's one way of looking at it. These apps are obviously more complex to build because you have a single application spread across cloud providers, versus you could have two different apps and you could decide that, okay, for the first app, because maybe it's a .NET app, it's a lot more easier to deploy it on Azure, given that it's Microsoft's. And then you have a Golang app, which you want to orchestrate using Kubernetes, and you might find that it's a lot more easier to deploy that on Google Cloud. So this gives a quick comparison of what different platform as a service tools are provided by the three big cloud providers. And this information is publicly available, so I won't go through these in detail. But the important aspect to see is almost every provider of the top three or the big three provides you equivalent PaaS offerings. So, if it is machine learning on Azure, you have Azure ML. On AWS, you have SageMaker, and on Google Cloud, you have machine learning engine. So the technology choices are in front of us. It's just now up to us to pick the right tool. So, the question is, how do we pick the right tool, and do we really need to be multi-cloud? So there are, I feel, three important questions when it comes to, upfront deciding whether we even need a multi-cloud strategy or not. So first one would obviously be what is called as switching cost. So let's say if you're on one provider, it makes sense because everything is in the end, driven by the dollar value of what you do, right? So, what would be the cost of switching if we had to leave your current provider? So it could be AWS, you might be having an app running on Azure. So, one way to see is ask yourself a question, what it takes if today my app is running on AWS, what it takes to run it on Azure or GCP. So that gives you an idea about the cost involved, and the cost is not just the money, it even involves the time it takes, and it's not just about, changing your DevOps or CI/CD process to now deploy to the new platform, but as we spoke about earlier on the vendor lock-in, it could also be about having to refactor or re-engineer the application itself. So once we have figured out the cost, the next question is obviously going to be the likelihood. What are the chances that you would be switching from one provider to another? And once you have figured these two parts, then it's all about when you're building an application or architecting an application is how do you minimize the risk? So when we talk about risk, it's the switching cost, it's about redundancy, it's about, what if a disaster occurs? Is it okay for the business to be down if a cloud is down? A lot of times, I've heard people say, hey, I can't do anything about it, Azure is not working. Or hey, I can't do anything about it, the Route 53 on AWS stopped working. So if that's okay with business, that's fair enough, but it's always important to ask, what if something goes wrong on the cloud side, not on your application side? Is the business okay to take that downtime? So now that we have, spoken about multi-cloud, what and why, the question comes, how do you go about doing it? So I think one of the key things is, in the design process is to make sure that whatever we are building is loosely coupled. We are creating facades using containers so that, if we follow these kind of best practices, we are not just making it easier to switch cloud providers, we are actually making it easier to switch any sort of platform provider. So, it's kind of fairly, critical to make sure whatever we are building, so nowadays there's a lot of buzz about microservices, event-driven architecture, sagas. So they're not just buzzwords in a way; they're kind of the way of building applications. So how do we make sure whatever we are building doesn't really causes us any deep integration issues where one component cannot live without another. So it's all about how you make use of the queuing, the events, and build everything as lightweight as possible. So the general thumb rules of building on top of a multi-cloud strategy when it comes to an application is to focus on microservices and serverless. So when we talk about serverless, we are talking about lambdas, Azure functions, and even the Google functions. So that is very critical. That whatever we build, we think containers, we think Docker instead of the PaaS web apps. So everyone has a PaaS web offering, be it app service or a cloud service in Azure, or a Beanstalk or an EC2, whatever in AWS, right? So we need to think how we can build everything as containerized app, right? And how can we make use of serverless? When we say serverless, it's obviously not running without any servers, but you're pretty much taking out a lot of dependency on the vendor hardware out of the equation. So, if you, let's say, have a search microservice instead of, let's say if your application had a search need, and if you hadn't built it as a monolithic search component being kind of integrated into all of your other modules, instead if you had a microservice, and it's much easier for you to now just take the search microservice out and put it on AWS so that you can maybe use Elasticsearch, or if you wanted to use an Azure search PaaS offering, you can move it, your entire search microservice, to Azure, whereas all your other apps can run wherever they are running, right? So that's one of the key of using a microservice-based architecture. The other thing, as I said, serverless takes out the dependency on the hardware, right? And it kind of, in a way, forces you to think more microservices and event-driven. One of the key challenges with the serverless is the cold start, though. So, you need to kind of watch out for that. So, if you see, even if it is microservice or serverless, one of the key component is containers. So, I felt it would be kind of nice to take a quick detour on what is a Docker, right? So a Docker container is basically a standard unit of software, that packages a code and all its dependencies, so that the application runs reliably from one computing environment to another. So you could think of Docker as pretty much like infrastructure as the code, and even your basically application all bundled as one piece. So one of the key advantages of Docker is that since you are also bundling not just your application, but even all the dependencies, including the operating system, the exact version of the packages that you deployed, you're bundling everything together. There's no more works on my machine syndrome, because everyone gets exactly the same thing. And I would really recommend that even in the development process, while we are building applications, especially if you're looking at Linux-based or Node, PHP, Golang, Python kind of stack, I would recommend that even then, building your or developing your code within a Docker container will save you a lot of headaches later. Windows containers are there, so if you're looking at, let's say, .NET Core, you could always do it on Linux. But Windows-based containers are a little pain right now, so if you have a .NET standard framework, it's a little hard to get that up and running without having serious performance issues. But otherwise, even during the development cycle, I would recommend using Docker containers. And even if you have to go with a PaaS-based web offering, be it Azure App Service, Beanstalk, or Google App Engine, they all support hosting single or multiple Docker containers. So, even if you couldn't directly move to a more microservices-based architecture, it makes sense to, at least as part of the journey, move to containers and deploy the containers and then later refactor the code over a period of time. And almost every one of them have Docker container management solutions, like Azure has container instance, AWS has Fargate, and so basically if you already have an application and you wanted to move more towards microservices route so that you could kind of deploy and cherry pick components across cloud, I would recommend start off with the Docker, deploy that on your compute engine, whatever cloud provider you're using, and move it to more like a managed Docker management offering, be it Fargate or container instance, and then switch over to more complex microservices scenario, be it using Azure Kubernetes Service or Elastic Container Services and so forth. So once we spoke about the microservices and we spoke about serverless, there are a few new kids on the block that wish it would really help if you should kind of read up about these. So Google Anthos is one which is currently in a private beta, but what it lets you do is it lets you basically run an app anywhere. So what we talk about is you write your code, and then Anthos does its magic so that you could run it on existing on-prem infrastructure, or you could run it on the public cloud without any modifications. So everything just runs as is. It's just a matter of bundling it in Anthos, setting some configuration values to say, hey, I want it on Azure versus I want it on Google Cloud, and Anthos takes care of the rest. So Anthos is a pretty key tool to look out for this year, and if it really delivers on what it promises, quite a lot of things right now are experimental, but if it really delivers on what it promises, I think it would be a real game changer when it comes to the multi-cloud strategy. The other is obviously serverless.com. It's an open source CLI tool which lets you bundle and deploy your serverless components across the cloud providers. So it just takes a matter of CLI command to say serverless deploy Azure versus serverless deploy GCP, and it automatically configures all the cloud vendor settings for you based on the language you use and provider you deploy to. So these are the few new things that have come up. We should be taking a look at these and see how we can fit these in our multi-cloud strategy. So that pretty much covers what I had in terms of the multi-cloud. So in case you guys have any questions, feel free to drop me a note at the email address over here, and I would be more than happy to take those questions and reply back to them. And as I mentioned in the first slide as well, if you need to reach out to me, I'm available on LinkedIn. You can easily look me up, or on Twitter, and we can get connected that way. So thanks everyone for your time. Hopefully this webinar was a little helpful and you did get some insights into how you could move about, or go about moving to a multi-cloud strategy. The key takeaways, just to recap, would be, running Docker containers, serverless, Google Anthos, and kind of not doing a vendor lock-in by tying very deeply, keeping things very loosely coupled when it comes to the different cloud SDKs. So thank you, everyone. Bye now.